Assalamu alaikum. Today we are going to solve 9709 paper 4-2, which is Mechanics M1, May June 2023. Our first question is, a particle of mass 1.6 kg is dropped from a height of 9 meters above horizontal ground. Speed of the particle at the instant before hitting the ground is 12 meters per second. Find the work done against air resistance. So let's do this. First, I'm going to make a diagram. So suppose this is our particle and we dropped it. Its weight is given, and that is 1.6 g. So our height is also given, and that is h is equal to 9 meters. And he says, the examiner says, the speed of the particle at the instant before hitting the ground is 12 meter per second. So suppose when the particle reaches near the ground, its velocity, which we will call it final velocity, would be equal to 12 meter per second. And here we can write initial velocity when we start dropping it would be 0 meter per second. So we will use this formula, and let me write it in wording first. Work done by applied force which we can name it as WDF, work done by applied force, minus work done by frictional force and we can name it as WD, work done by frictional force, and write it as F, and that is created by the air resistance, and that would be equals to kinetic energy plus potential energy at the base. Let me write it here, at the base minus kinetic energy, I can write it in short words, plus potential energy at the top So now we will write down all the values in this formula. So when we drop the particle, there would be no applied force. It means work done by the applied force is 0. So our formula shapes something like this. First let me write its shape. WDF minus work done by the friction force, and that is equal to kinetic energy plus potential energy at base minus kinetic energy plus potential energy at the top. So as I said, when we drop the particle, there would be no applied force, so it means the applied force is 0, so I'm going to write 0 here, minus work done by the frictional force is to be known, and that is equal to kinetic energy. The formula is 1/2 mv square plus the formula for potential energy is mgh minus same thing, let me write it here, half mv square plus potential energy is mgh. So let me write the values in it. So half mass is 1.6 times velocity is 12 squared plus the potential energy at base is 0, and now at the top the kinetic energy is 0. So we can, instead of writing its values, we can write directly 0 here, plus the mass in potential energy is 1.6 times g is over 10 and the height is 9. So this becomes very simple, and your work done. Against resistance against air resistance will be equals to, if you solve this with the help of your calculator, your answer should be 28.8 joules. In question number 2, two particles A and B of masses 3.2 kg and 2.4 kg respectively lie on a smooth horizontal table. A moves towards B with the speed of v meter per second and collides with B, which is moving towards A with the speed of 6 meter per second. In the collision, the two particles comes to rest. Find the value of v. So if we make its diagram, say this is particle A and it is moving towards B, and here this is particle B, it is moving towards A. So take the direction of A moving toward B is positive. So after collision, both particles stop. It means their final velocity would be 0 after collision. So I should write here the mass of A equals 3.2 kg and the initial velocity of A is given as v meter per second. The mass of B is 2.4 kg and the initial velocity of B is given as minus 6 meter per second, because I have taken the direction of A as positive, so definitely the direction of B must be negative. Now we use the formula conservation of linear momentum. And it says MAUA plus MBUB equals MAVA plus MBVB. So mass of A is 3.2 times initial velocity is v plus mass of B is 2.4 and initial velocity is negative 6. So mass of A is again 3.2 and velocity is 0. This is actually 0 is written because after they collide their final velocity becomes 0. So that's why I'm writing 0 here. Plus mass of B is 2.4 and the same thing with V here, 0. So actually this side, the whole side becomes 0. So this is 3.2 V plus minus is minus 2.4 times 6 is 14.4 and this is equal to 0. From here your V is 4.5 meter per second. This is your answer for part A. In part B he says find the loss of kinetic energy of the system due to the collision. So here in this part our formula is something like this. You can say initial kinetic energy is equal to final kinetic energy. This is called conservation of mechanical energy. So my initial kinetic energy would be equals to half mu square. This is for particle A plus half mu square this is for particle B. Now if we place the values we will get 1 over 2 times the mass of A is 3.2 times our velocity is initial velocity is 4.5 square, which we just found out in the previous part, plus half mass of B is 2.4 times, and its initial velocity is negative 6 square. When you solve all of it, you will get 32.4 plus 43.2, which is 75.6 joules. So loss of kinetic energy would be same, and that is 75.6 joules. This is our answer for part B. For question number 3, coplanar forces of magnitude 30 Newton, 50 Newton, 33 Newton and P Newton act at a point in the direction shown in the diagram where tan alpha equals 4 over 3. The system is in equilibrium. Show that this whole thing is equal to 1. So we can resolve the forces vertically. So if I resolve the forces vertically, this would be my 15 sine alpha. Here my force would be 30 sine theta. This one is P p sine theta, and this one would be 33 sine alpha. So vertical forces would be 15 sine alpha plus 30 sine theta, and that would be equals to p sine theta plus 33 sine alpha. So collect the like terms. 30 sine theta minus p sine theta, this is equal to 33 sine alpha minus 15 sine alpha. From this part, if I can take sine theta as common, I can write 30 minus p in the bracket, and this is equal to, we can solve 33 sine alpha minus 15 sine alpha, so it becomes 18 sine alpha. If I make the triangle, right angle triangle, because in the question examiner has given us tan alpha is equal to 4/3. So if I place alpha here, my tan is opposite over adjacent, means 4 here and 3 here. So whenever you have two values, 3 and 4, no need to use the Pythagoras theorem. You can straight away write hypotenuse as 5. This is for the values 3, 4 and 5 only. So from here I can find out the value of sine of alpha now easily. Opposite over hypotenuse. Sine alpha would be equal to 4/5. So place this value here. So sine theta 30 minus p equals 18 into sine alpha is 4/5. So sine theta 30 minus p equals, solve this, you will get 14.4, and sine theta would be equals to 14.4/30 minus p. This is your equation number 1. Now resolve the forces horizontally. Means in this direction. So all of them would be in cos. So you write 15 cos alpha plus 33 cos alpha is equal to 30 cos theta plus p cos theta. If I can show you in the diagram with the blue color, so that would be equals to 15 cos alpha, and the 33 Newton would be in the same direction, 33 cos alpha, and here 30 cos theta, and the downward would be P cos theta. Now 15 cos alpha plus 33 cos alpha makes 48 cos of alpha, and equals to, you take cos theta as common, so you will get 30 plus P in the bracket, and from that diagram in the blue right angle triangle we can also find the value of cos of alpha. Cos of alpha would be adjacent over hypotenuse or base over hypotenuse, 3 over 5. So write this here with 48. 48 times cos alpha is 3 over 5. This is equal to cos theta times 30 plus P. So 28.8 equals cos of theta, which is 30 plus P, and make cos theta subject. You will get 28.8 divided by 30 plus P. This is your equation number 2. Now use the identity sine square theta plus cos square theta is equal to 1. Now our sine square theta would be 14.4 over 30 minus P squared plus 28.8 over 30 plus P whole squared is equal to 1. And now you can write shown. This was required in this part. Our part B is verify that P is equal to 6, satisfy this equation and find the value of theta. So from the previous part, I'm writing it again, 14.4 over 30 minus P whole squared plus 28.8 over P plus 30 whole squared is equal to 1. Now in the left hand side we can use when P is equal to 6, what will happen. So I'm going to write 14.4 over 30 minus 6 in place of P whole squared plus 28.8 over 6 plus 30. I'm using left hand side only. Now if I solve it, I will get 0.6 squared plus 0.8 squared, and further when you solve it you will get 0.36 plus 0.64, and finally you will get 1 from this, and this is your right hand side. So we can say P is equal to 6 satisfies the equation. Now in the second part he said find the value of theta. So you can pick sine theta or you can also pick cos theta. So I'm going to pick sine theta from part A, which was sine theta is equal to 14.4 over 30 minus P. I got the value of P, which I'm going to place here. 14.4 over 30 minus 6, which is If you solve whole of it, this fraction, you will get 0.6. So can I write sine theta is equal to 0.6, and from here theta is equal to sine inverse of 0.6, which is 36.9 degrees. And this is your answer for this part. Question number 4. An athlete of mass 84 kg is running along a straight road. In part A, initially the road is horizontal and he runs at a constant speed of 3 meters per second. The athlete produces a constant power of 60 watt. Find the resistance force which acts on athlete. So this is a 1 mark question and a very simple question. We just use the formula for power is equal to force into velocity. So power is given 60 watt and force is to be known. So velocity is 3. So from here our force is 20 Newton. In part B, it's a 6 mark question and a detailed one. The athlete then runs up a 150 meter section of the road which is inclined at 0.8 degree to the horizontal. The speed of the athlete at the start of this section of road is 3 meters per second. And he now produces a constant driving force of 24 Newton. The total resistive force which acts on the athlete along this section of road has constant magnitude of 13 Newton. Use an energy method to find the speed of athlete at the end of the 150 meter section of the road. Okay, let's draw a diagram for this first. Suppose this is an inclined plane which is at 0.8 degree and our athlete is suppose here. So his driving force is 24 Newton and the section length is 150 meters. Initial velocity is also given, which is 3 meters per second, and his mass is also given, 84 kg. So resistive force is 13 Newton. So our final velocity is to be calculated when it reaches up the inclined plane here. So first of all, we should try to find out the height. So opposite over hypotenuse is sine theta. So I can write sine 0.8 equals opposite over hypotenuse, which is 150. This gives me h equals 150 into 0.8. Sine of 0.8. And this gives me 2.1 meters height. So now let's try to solve it. We would apply work energy principle. So that is total work done is equal to increase in mechanical energy this actually total work done is based on driving force minus resistive force. And that is equal to increase in mechanical energy, which is increase in kinetic energy plus increase in potential energy. Further, the increase in kinetic energy is actually final kinetic energy minus initial kinetic energy plus, and increase in potential energy would be final potential energy minus initial kinetic energy, initial potential energy. So our driving force is Fd, means force into distance. So let's start writing it from here. 24 times, and distance is 150, minus resistive force is 13, which is opposite, and times its distance, the same 150. This is equal to final kinetic energy, means half mv square. So half mass is 84 and v is to be known, minus initial kinetic energy half mv square, m is 84 and v is given 3 meter per second, it's a square, plus final potential energy, so that would be mgh, mass is 84 and g is 10 and h is, we just found out there, 2.1, minus initial potential energy. Again use mgh, mass is 84, g is 10 and height is 0 there. So this side all will become 0 and now try to solve it. 1650 equals 42v square minus 378 plus 1764 and 1650 equals 42v square minus plus, you subtract 378 from 1764, you get 1386, and now isolate v square, so 1650 minus 1386 is equal to 42v square. So this will be 264 divided by 42 and that is your v square. So v square would be equals to 6.28 and v would be equals to 6.28 square root and v is your 2.5 meter per second, and that is your answer for this part. In question number 5, a particle of mass 0.6 kg is placed on a rough plane which is inclined at an angle of 35 degrees to the horizontal. The particle is kept in equilibrium by a horizontal force of magnitude P Newton acting in a vertical plane containing a line of greatest slope. The coefficient of friction between the particle and the plane is 0.4. Find the least possible value of P. So let's make the diagram again here. This is 35-degree angle here. This is our P. And weight is 0.6 kg. So let me extend it. P Newton. So my R is the normal reacting force is here, and my weight is here. So this makes 90 degrees. So my angle, alternate angle, comes here 35, and also here is 35. So now resolve the forces perpendicular. Okay, one more thing. Here is my frictional force, because it is going to slide down, so my frictional force will be in the opposite direction. So this is my 0.6 g weight. So resolve forces perpendicularly to the plane, so for that the arrow marks like this in this way. So my R would be equals to 0.6 g cos of 35 plus P sine of 35. Now the frictional force is written as Fr. This is actually mu R. So my frictional force would be equals to, mu is given as 0.4, and 4.91. This is from 0.6 g cos of 35 plus P sine 35. Sine 35 is 0.57. So I write 0.57 P. Further, if I simplify this equation, so Fr becomes 1.964 plus 0.57 P. This is my Fr, frictional force. Now resolve the forces along the plane, and for that my arrow will go in this direction. This is along the plane. So along the plane I have to resolve forces like P cos 35 plus Fr, frictional force, that you can see Pn and Fr. This is equal to 0.6 g sine of 35. That would be in the opposite direction. 0.6 sine of 35 will go in the opposite direction. So along the, when you resolve along the plane, so that would be sine of 35. So from here, P cos 35 plus my Fr is actually from this value. This is my Fr. So I'm going to write 1.964 plus 0.57p, and this is equal to 3.44, which comes from 0.6 g sine of 35. So 0.819p. This is P cos 35 plus the like terms. I'm collecting the like terms together. 0.57p is equal to 3.44 minus 1.964. So 1.389p equals 1.476. So from here p is 1.476 divided by 1.389. So my p would be equals to 1.06, or it is 1.1 Newton, or if after the decimal value, if there is a difference, then it can be from the values which I took in the whole solution. I should take up to at least 3 decimal places. So somewhere I took 3 decimal places and somewhere I took just 2 decimal places. So it's not a big thing. Your answer is 1.1 Newton, or maybe a little more than that. So this is your final answer for this. In question number 6, a particle P starts at rest and moves in a straight line from a point O. At time t second after leaving O, the velocity of P v meter per second is given by v is equal to bt plus ct power 3 over 2, where b and c are constants. P has velocity 8 meter per second when t is equal to 4 and has velocity 13.5 meter per second when t is equal to 9. Show that b is equal to 3 and c is equal to 0.5. So, okay, our v equals bt plus ct power 3 by 2. When t is equal to 4, our velocity is 8, v is 8. So we can write 8 equals b times 4 plus c times 4 power 3 by 2. So if you simplify this, you will get 8 equals 4b plus 8c. Now further simplify, so you divide it by 4 throughout and you will get 2 equals b plus 2c. b plus 2c. And make b the subject from here. So you will get b equals 2 minus 2c. So this is your first equation. Now we can use, initially when p start moving, so at that time our initial velocity was 0 and t was 0. So when t is equal to 9, our velocity is 13.5 meter per second. So put this in the equation. In velocity we write 13.5 equals 9b plus 9 and c is power 3 by 2 c. Simplify this. 13.5 is equal to 9b plus 27c. Now substitute the value of b from equation 1 here in b. So you get 13.5 equals 9 into 2 minus 2c plus 27c. From here, when you calculate c, the value would come out as negative 0.5. Now this is, we have shown c is equal to negative 0.5, and now we have to find b. So you put this value of c in equation 1 to find b. So b equals 2 minus 2 into minus 0.5. So you will get b, the value of b, which is 3, and you can write shown. In part B, find the acceleration of p when t is equal to 1. So acceleration is derivative of velocity, dv over dt. So write down the equation of velocity, which is 3t minus 0.5 t power 3 by 2. Now derivate it, so dv over dt would be equals to 3 minus 0.5 times, bring down the power 3 over 2, subtract 1 from 3 over 2, and that would be 1 over 2. So your acceleration is 3 minus 3 over 4 t power 1 by 2. Now when t is equal to 1, your acceleration is 3 minus 3 over 4 1 power 1 by 2. So your acceleration would come out as 2.25 meter per second square. That is your answer for part B. Find the positive value of t when p is at instantaneous rest, and find the distance of p from O at this instant. So t is to be known when v equals 0. Why v is equal to 0? Because when p is at instantaneous rest, so velocity becomes 0 there. So you can write v equals 3t minus 0.5 t power 3 by 2, and put 0 in velocity, and 3t minus 0.5 t power 3 by 2. Take t as common, so it will become t as taken as common. So in the bracket you are going to write 3 minus 0.5, and t power 3 by 2 divided by 3 will give you t power 1 by 2. So one, your t equals 0, and other your 3 minus 0.5 t power 1 by 2 equals 0. So from here your 3 is equal to 0.5 t power 1 by 2. So 3 divided by 0.5 is equal to t power 1 by 2, and this 6 is equal to t power 1 by 2. Now squaring both sides will give you 36 is equal to, square will cancel 1 by 2, so your t is equal to 36. And in the second part we have to find the distance of p from O at this instant. So distance is the integration of velocity equation. So s is equal to integral of the velocity equation is 3t minus 0.5 t power 3 by 2 dt. So now integrate it. So your this would be 3t power 2 over 2 minus 0.5 t power, you add 1 in 3 by 2, you get 5 by 2 divided by 5 by 2 plus c. So now simplify this one. So you will get s is equal to 3 by 2 t square minus 1 over 5 t power 5 by 2 plus c. So when t is equal to 0, your s was 0. So put 0 in s and 0 in t. minus 1 over 5, 0 power 5 by 2 plus c. So finally you will get the value of c is equal to 0. So now your equation becomes s is equal to 3 over 2 t square minus 1 over 5 t power 5 by 2 because c was 0. Now when t is equal to 36, what would be our distance? So s is equal to 3 over 2 times square of 36 minus 1 over 5, 36 power 5 by 2. So your s is equal to 388.8 meters. So your 3SF would be 389 meters. 3SF. In part D, find the speed of P at the instant it returns to O. So when the particle returns to O, the displacement becomes 0. It means S is equal to 0. So your equation for the distance is 3 by 2 t square minus 1 over 5 t power 5 by 2. So 0 is equal to 3 by 2 t power 2 minus 1 over 5 t power 5 by 2. So 0 is equal to, you take t square as common, so you get 3 by 2 in the bracket minus 1 over 5 t power 1 by 2. So you got two factors, t square equals 0. From here your t is equal to 0, and other ways 3 over 2 minus 1 over 5 t power 1 by 2 is equal to 0. So 3 by 2 is equal to 1 over 5 t power 1 by 2. So 3 by 2 into 5 is equal to t power 1 by 2. 15 by 2 is equal to t power 1 by 2. And 15 by 2 is 7.5 is equal to t power 1 by 2. Now square both sides to remove power 1 by 2. So this is gone. So square of 7.5 is, your t would be equals to 56.25 seconds. Now find the speed. So v is equal to 3t minus 0.5 t power 3 by 2. So your velocity is 3 times 56.25 minus 0.5 times 56.25 whole power 3 by 2. When you solve the whole thing, you will get velocity negative 42.18 meter per second. But because he asks you to find the speed, so you just ignore the negative sign because the speed is a scalar quantity. So you can write speed is equal to 42.18 meter per second. That's your answer. Question number 7. Two particles P and Q of masses 2 kg and 0.25 kg respectively are connected by a light inextensible string that passes over a fixed smooth pulley. Particle P is on an inclined plane at an angle of 30 degrees to the horizontal. Particle Q hangs below the pulley. 3 points A, B and C lie on a line of greatest slope of the plane with AB is equal to 0.8 meter and BC equals 1.2 meter. Particle P is released from rest at A with the string taut and sliced on the plane. During the motion of P from A to C, Q does not reach the pulley. The part of the plane from A to B is rough, with coefficient of friction is 0.3 between the plane and the P. The part of the Plane from B to C is smooth. In part 1, find the acceleration of P between A and B. Okay, quickly we should resolve some forces, and suppose can I write tension here, and if I extend this, the frictional force, which I write as Fr, this also goes opposite to the movement of the P, because he said from A to B it is rough plane, so there must be a frictional force. So if I see this resolving my normal R here, and here goes the weight, and that is 2 kgs, it means 2g. Acceleration is in this direction. Tension here is in this direction, and here goes 0.25 g. I think this is enough, and let's start solving it with the red color. If I resolve perpendicular to the plane, the arrow goes in this direction. It means it is perpendicular to the plane. So my R equals 2g cos 30. If 30 is here, my 30 goes in this direction. So R becomes 17.32. Now frictional force is equal to mu R. So mu is given 0.3, and my R is 17.32, which I just found out. So my frictional force is equal to 5.196. Now use the Newton's second law of motion, which is F equals ma. My F is 2g sine 30 minus the frictional force Fr plus T, and this is equal to mass is 2 and air is A. Okay, 2g sine 30 minus Fr plus T. Look, the weight is 2g, which is sliding down the slope, and the opposite forces are frictional force as well as the tension. So that's why I wrote 2g sine 30 minus Fr plus T is equal to 2a. So 2g sine 30 is 10 minus my Fr is 5.196 plus T, and this is equal to 2a. Now 10 minus 5.196 minus T is equal to 2a. If you further simplify it, you will get 4.804 minus 2a is equal to T. This is my first equation. Now for the second equation, we can work with the particle Q. Again, use F equals ma, and for particle Q, my force would be T minus 0.25 g is equal to, my mass is 0.25 and A is A. This is my second equation. You can I can show you this. Look at the particle Q. The weight is 0.25 g and the tension is in opposite direction. So put the value of T from equation 1. In equation 1 we have already made T the subject, so the value of T is 4.804 minus 2a, so write it here in T in equation 2, which is 4.804 minus 2a minus 0.25 g and that is equal to ma. Mass is 0.25 a. Now further simplify this equation, you will get 4.804 minus 2.5 is equal to, actually I am collecting the like terms, 0.25a plus 2a. From here you will get the value of a, which is 1.024, or you can write 1.02 meter per second square. This all work was from A to B. Alright. Now in part 2, from A to B, let me find out the velocity. So I'm going to use v square equals u square plus 2as. So actually this is from A to B, so my velocity at B would be, initial velocity was 0, 2 into acceleration was 1.024 and my distance is 0.8 meters. So velocity at B would be finally 1.28 meter per second. Now from B to C, use the previous equation but without frictional force because the surface is smooth. From B to C the surface is smooth. So can I write it? F is equal to ma, and my F is 2g sine 30 minus t is equal to 2a. So 2g sine 30 is 10 minus t is equal to 2a. This is my third equation. Now for particle Q, because it's also moving up, there is no change. What I mean by change, actually no change in its equation. So I can write t minus 0.25 g equals 0.25 a. So t minus 2.5 equals 0.25 a This is my fourth equation. Now equation 3 can be written as 10 minus 2a equals t. Put this in equation 4. So 10 minus 2a minus 2.5 equals 0.25a. So 10 minus 2.5 is 7.5, and send minus 2a over there on the other side of is equal to sign. So 0.25a plus 2a will make it 2.25a, and from here your a is equal to 7.5 divided by 2.25, 3.33 meter per second square. Velocity at c, so v square is equal to u square plus 2as. So v square is equal to, our initial velocity is now 1.638 square plus 2 into acceleration is 3.33 and distance is 1.2. So our answer is v is equal to 3.1 meter per second. Now this is actually, we can write speed is equal to 3.1 meter per second. I don't have any space left, so let me do it here on the next page for part B. So A to B, I'm going to use V is equal to V is equal to U plus AT. So 1.28 is equal to 0, initial velocity was 0, plus my acceleration was 1.024 t. So from here my t is 1.25 seconds. Actually I'm solving this second part which I wrote it by mistake as B. So that part was, our answer was here. So okay, now from B to C, again I'm using V is equal to U plus AT. My V is 3.1046 equals my initial velocity is here 1.28 plus acceleration is 3.33 and my t is t. So from here my t is equal to 0.547 seconds. Now time from A to C is 1.25 plus 0.547, and that is 1.8 seconds. And that's it. Find the time taken for P to travel from A to C. Speed of P at C, 3.14. Okay, let me correct it. This is our part B, and I have done part 2 in red. So let me, V is equal to velocity at C. Okay. Okay, let me do it again on the next page. Velocity at C. So this is V square equals U square plus 2AS. So V square is equal to 1.638 squared plus 2 times 3.33 into distance is 1.2. So our V square would be equals to 9.638. So V is 3.1 meter per second. So speed of P at C is 3.1 meter per second. So actually this is a continuation of this working. So you can combine it and you can understand it. So that is our answer.